In this video, we're going to just look at the basics of integration. Now, most of this we should know already from AS1. So if you have the function y, which is equal to a function of x, such as y is equal to 3x squared, y is equal to 1 plus 3x squared minus 7, 3x squared plus 2000, then if you differentiate that, you get your f dash of x. So all these functions when differentiated, give dy by dx is equal to 6x. Hence, when integrating, doing the opposite then, so the integration is the opposite of differentiation. So if you integrated 6x, it would take you back to y is equal to 3x squared plus c. So if you have a look at a few of these, here the c would be 0, here the c would be plus 1, here the c would be negative 7, and here the c would be positive 2000. So we don't know what the c is. It's called our constant of integration. Okay, so if we look at the integration then, it as a reverse process of differentiation. So if you start with your dy by dx, which is f dash of x, then when you integrate, you will get y is equal to f of x plus c, where that is c is your constant of integration. The general rule for integration then, so you should have seen this in your AS1 and also your GCSE Further Maths. If you integrate ax to the power of n, what you do is you raise the power by 1 and then you divide by the new power. So this works for all positive and negative values, positive, negative, or fractional values of n, except n equals minus 1. And we'll see a bit later on what we do if n is equal to minus 1. So for any other value of n, this works. So again, just to run through it again, you increase the power by 1, and then you divide by the new power. So it's the opposite process of integration. And it says here, do not forget the plus c. So first of all, we're going to look at ones without limits. Without limits is called indefinite integration. It has to have limits to be definite integration. So we're just going to jump and look at the first lot of examples here. Okay, the first one here, we're just going to work down our page. So we've integrated. So you raise the power of everything by 1. So the x goes up to x squared goes up to x cubed. Divide by the new power. So you're dividing by 3. Then the power here is really a 1. So you add 1 to 1 and you get 2. And you divide by your new power. And this, I'll just look at this minus 2. That's really minus 2x to the power of 0. So when you integrate that, it comes up to x to the power of 1 divided by 1. And then remember your plus c. Okay, I would never do this, to be honest. I would just know if you integrate a constant, and minus 2 is a constant, you just get that constant times x. So for example, if you integrate 7, you'll get 7x. If you integrate 5, you get 5x. Integrate 14, you'll get 14x. So here, just tidy that up and write that a wee bit nicer. It's just going to be x cubed over 3 plus 3x squared all over 2. Oops, sorry, that should be minus 2x plus c. So we'll just get rid of that. Okay, next example. The first thing we've got to do here is to get it in index form, because it's not in index form at the minute. So putting this in index form, that's x to the minus 3 being integrated with respect to x. And same idea as before, you raise the power. So minus 3 plus 1 takes you up to minus 2, and you divide by your new power. Also, don't forget your constant of integration. Okay, let's just separate this out. That is minus 2 in the bottom line, so that's the same as minus a half times, and x to the minus 2 is 1 over x squared plus c. So then for that fraction, multiplying on the top, minus 1 times 1 is just minus 1. Multiplying on the bottom, you're going to have 2 upon x squared. And I like to have a nice horizontal line so you can see clearly that minus 1 is being divided by 2 upon x squared. Last example for us here. Again, before we get started, write it in index form. So square root of x is x to the power of a half, plus that's going to be 3 over 2 upon x to the minus 2. That's being integrated with respect to x. Okay, when you're integrating with respect to x, you're raising the power by 1, it's a half. Half plus 1 is 1.5. Don't write it as 1.5 or even worse, 1.5. Write it as an improper fraction, 3 over 2. Now the reason for this really is it makes it an awful lot easier when you then divide by the power. So dividing by 3 over 2 is the same as multiplying by 2 over 3. So when I divide by 3 over 2, it's the same as multiplying by 2 over 3, so 2 on the top line, 3 in the bottom line. And over here, we're going to have our 3 over 2, and raise the power by 1, it's going to be minus 1, and divided by minus 1, and plus your c. And then tidy that all up, you have 2 times x to the power of 3 over 2, all divided by 3, and then that's going to be minus, and 3's on the top line, the 2's on the bottom line, and the x is also on the bottom line, and that's it. Okay, you are now ready to do topic 7. Topic 7, exercise 1. Now, in this exercise, it also has definite integral examples. So I'm going to change my, I'll do my second one because it's the easier one. I'm going to change my second example now just to be a definite integral one so you can see what it would have become. So let's pause the video and do a wee bit of editing here. Okay, so I've changed my example 2 to have limits this time. So let's just work through how we do this. The same first step as we had at the previous time was get this in index form. So it's x to the minus 3 integrated with respect to x, and it's between minus 1 and positive 2. Now once we've integrated, we're going to go into square brackets, and the strange thing is your limits go to the right hand side. So raise the power by 1, it goes up to x to the minus 2 all over minus 2, which just becomes minus 1 over 2x squared, and that's between 2 and minus 1, or minus 1 and 2. Now we're going to have 2 square brackets, and what goes into your first bracket is your 2. So everywhere you see x in the first bracket, you replace it with 2. So it becomes minus 1 over 2 times 2 squared. And then the next one, minus 1 goes in instead of x, so you substitute minus 1 in instead of x, so it's minus 1 over 2 upon minus 1 squared. So tidy that up. Your first bracket would be minus 1 over 8, and your second bracket would be minus 1 over 2 times minus 1 squared is 2 times 1, which is just 2. So that's what you've got. So it's going to be minus 1/8 plus 1/2. Minus 1/8 plus 1/2. I haven't got my calculator, so I'm going to have to just work that out. That's going to be half, which is 4/8, minus 1/8, which is just going to be 3 over 8. But of course, at this stage, you could just put that into your calculator, minus 1/8 minus 1/2, and you would get 3/8, and that's it. Okay, you're now ready to do topic 7, exercise 1.